Hello students, welcome to another week of lab. I hope y'all are doing well. In this video, I am going to be reviewing some of the families that we learned in Module 10's lecture videos. If you haven't already seen those, please go back and watch those first because Erica goes into a lot more detail about those families than I will today. And those families were the Apocynaceae, which are the dogbane family, the Onagraceae, or the evening primrose family, and the Gentianaceae, or the gentian family. And for the purposes of this video, I'm actually not going to cover the gentian family. It can be a little hard to identify, and frankly, there's enough to talk about with the first two. So let's get into it. Starting with the Apocynaceae, this is quite a large family, and it recently became larger because the Asclepius family, aka the milkweeds, were merged together with this family. And I have a note here that I know for a fact that some of you have collected milkweeds for your projects. If you haven't already identified those, this video may help some of you. So pay close attention as I begin talking about these traits. So as for their habits, their growth forms can be variable, but many have a milky latex, which is a great trait to look for. If you damage the plant in any way, this white latex will spring forth, and it can be very sticky if you get it on yourself. I have tromped through many prairies, have probably crashed into a few of plants from this family, and you can get covered in very sticky latex pretty quick, especially if it's been like a wet year. They produce a whole lot. Good trait to look for. So as for their leaves, their arrangement is typically opposite, but can be alternate or whorled. There are no stipulates on these leaves, and they are simple leaves with entire leaf margins. I really like looking for that trait. Simple leaves, entire leaf margins. There are what I call two different types of flowers. On the left are the quote-unquote regular flowers, and then on the right is a picture of the Asclepius flowers, which are quite different. But in both of them, they are perfect in actinomorphic. Here are their flower formulas. On the left, we have regular flowers, right, Asclepius flowers. There are a lot of commonalities with these formulas. They both have a 5-5-5-2 structure. And looking at these formulas, you would only think that there's differences in how these structures are fused and fused to each other. Let's go more into depth with that. So looking at the regular flowers, we have 5 sepals that can be fused or distinct. We have 5 fused petals that are adnate to the stamen, which there are 5 of. And then we have 2 gynoecium, 2 carpellate gynoecium, and that is a superior ovary. In the Asclepius flower, 5 sepals, 5 fused petals, which I'll mention why that's highlighted in just a moment. And then we have, let's see, 5 fused stamen and 2 fused gynoecium, which are adnate to one another. So the reason why I have that highlighted in the Asclepius flower formula is I really just want people to make the same mistake I did. When you look at these flowers, I would have sworn that those petals are distinct. They are not. And if you go in with that assumption and you try to, let's say, key out this family, you're going to get the wrong answer in the text, because I got the wrong answer in the text. I'm going to talk about, well, let's talk about that now. So here is a more detailed view of the structure of a typical Asclepius flower. Now, the petals might, again, look distinct, but they are fused to create a tube which goes from the petals up into this very specialized structure called the corona. So those fused petals make this corolla tube right here. That is why they are considered fused. So let's take a closer look at this structure. The corona has multiple features, multiple functions. It's a really, really cool structure. In the center of it, we have something called the gynoecigium, which has, let's see, the stamen, the androecium, gynoecium, all fused together in the center. And then there's a crown-like structure, if you look at it from the top here, that is composed of that gynoecigium. And let's see, the 5 hood structures and 5 horn structures. Incredibly cool flower. I love seeing them. They're also really neat because they create these structures called pollinium. They're basically pollen, waxy pollen, all squished together to form these structures that you see on the right. And they get stuck to pollinators that carry them away to other flowers. Super cool. I always love seeing these flowers. And admittedly, I'm pretty good at identifying Asclepias plants out in nature, but I learned a lot this week because I didn't know what was going on. I know what an Asclepias flower looked like, but I didn't know the structures or what they even were. I couldn't tell you what were the petals and what was anything else. So I learned quite a bit. Very cool flower. As for their fruits, they are follicles, which remember, follicles come from a single carpel and they dehisce along a single line. And let's see, these follicles are often going to be paired in this family because remember, this family are 2 carpels. And because follicles originate from a single carpel, it makes sense that they would be paired. There's follicle from one carpel and then a follicle from the other carpel. These seeds are often comose, which means that they have hairs, and those hairs help them in seed dispersal. So it helps them fly far away from the mother plant. And that is all I want to talk about for this family. Remember, any questions, you can let me know or go back to Erica's video for Module 10. Next, we have the Onagraceae, which remember is the evening primrose family. It is a pretty small family, but it's well represented in Colorado. So a good one to be familiar with. The habit can be variable, but mostly herbs. Leaves are simple, alternate, or opposite. Now, these traits are pretty common, so perhaps those aren't that useful for identification. But what is the unique floral formula. Really cool, very unique. So it's great to look for when you're trying to identify your plants. Their flowers are perfect, actinomorphic, or ranging to slightly zygomorphic. Their floral formula is 4-4-8-4. Going in depth to that a little bit more. We have 4 sepals, 4 petals, 8 stamen, and those are all adnate to each other. And there is a 4-carpellate gynoecium, syncarpus, and it is my bar is a little bit confused here, but it is an inferior inferior ovary. My overline there, Oboza is not trying its hardest, but that's okay. That's actually all I want to talk about with this family. Unlike the last, it doesn't have the same complexities. So let's move on. Now, to wrap this video up, I want to do a short, silly review of these families. So pretend that we are all in a meadow of flowers And some mad lad manager has decided that they are only going to plant individuals from the Apocynaceae family and the Onagraceae family. Just pretend. So in this pretty meadow, we see a bee like this with some fancy footwear. Tell me, which plant has this bee visited? Yes, indeed. It visited the Apocynaceae, or more specifically, it visited an Asclepias flower. We know that because they are the ones that produce these pollidium, which are what we see attached to the bee's feet. So we can get a better look. It is just, of course, another method of pollination. And I really love this picture on the right because you can really get a close-up view of all of those pollen granules. It's a cool structure, but it's really just like fused pollen. Super cool. Next question. You were walking through this meadow and you see a plant producing fruit like this. What plant family are you looking at? Indeed, you are looking at another Apocynaceae flower fruit. This is the follicle fruit, which remember originate from only one carpel. And so when you see a pair of fruit like this, you know that they're coming from a two-carpellate gynecium. And it cannot be, I'm covering up all my notes here with my face. It cannot be from a member of the Onagraceae family because they have four carpels. If they did produce follicles, it would be a little pairing of four, which of course is not what this is. Next question. What family does this flower belong to? This is a member of the Onagraceae. I think in this example, that four-lobed stigma is a dead giveaway that you are looking at a flower that has a four-carpellate ovary. Next up, we have this one. What family? Maybe that one's easy. This is another Onagraceae flower. We have 8 stamen, and the four-lobed stigma, it's kind of hard to see from this picture, but those 8 stamen should give it away. Just remember that these flowers can be zygomorphic, if just slightly so. And then last up, what family does this flower belong to? This is an Asclepias flower of the Apocynaceae. I admit when I'm identifying Asclepias in the field, I can tell from the flowers pretty darn quick. There's nothing else that really looks like this flower once you get to know it. So what I'm basically saying there is that you can tell that it's an Asclepias because of the way it is. I hope that's helpful. If y'all have any questions, of course, just send Erica or I an email. Stay well, y'all.